Let us try to prove that the derivative of sine x is equal to cosine of x. To do that, let us use the limit definition to show the derivative of sine x. So let's say that the given function is sine x. So this is our f of x. So to get f of x plus delta x, we just need to substitute x plus delta x to the x variable of the given function. So in this case, we would be having sine of x plus delta x minus the given function, which is sine x. This is our f of x over delta x as delta x approaches 0. Now, let us recall the sum and difference identities, which was covered in our previous videos, that if we have sine of a plus b, that would be equal to sine a cosine b plus cosine a sine b. In this case, let's say that x would be our a and then delta x is our b. And applying this formula, we can have sine x times cosine of delta x plus cosine of x sine of delta x minus sine x. We just need to copy this over delta x. Notice that sine x cosine delta x and then this term negative sine x has a common factor, which is sine x. So factoring that out, we can have sine x times cosine of delta x minus 1. So if we try to distribute sine x to the inside terms here, we have sine x times cosine of delta x is this part, and then sine x times negative 1 is negative sine x. And then let's just copy this cosine x times sine of delta x over delta x. Using addition theorem, we can express this as the limit of sine x times cosine of delta x minus 1 over delta x as delta x approaches 0 plus this part. So we have the limit of cosine x times sine of delta x over delta x as delta x approaches 0. Since this is approaching delta x, we can move sine x and cosine x. So we can have this as sine x times the limit of cosine of delta x minus 1 over delta x as delta x approaches 0 plus, for this part, we have cosine x times the limit of sine of delta x over delta x as delta x approaches 0. Next, what is the limit of cosine of delta x minus 1 over delta x as delta x approaches 0? Looking at this table of values, let's say this first column is delta x and this would be f of x. So as we can see, as delta x approaches 0, at 0 we are undefined, but we are looking at the value as we approach 0. So f of x get closer and closer to 0. So this part would be 0. And then what is the limit of sine of delta x over delta x as delta x approaches 0? So this would be the table of values for this function. So as we move closer and closer to 0, or let's say this is again delta x, the first column, and this would be f of x. At 0, we are undefined, but as we move closer and closer to 0, f of x get closer and closer to 1. So the limit here is 1. Therefore, this part would be 0, and this part is 1. So what's left would be sine x times 0. So this would be 0 plus cosine x times 1. So that would be cosine x. How about for the derivative of cosine x is equal to negative sine x? So let us use the limit definition. So the given function is cosine x, so that would be our f of x. So the f of x plus delta x would be cosine of x plus delta x. Again, we're just going to substitute x plus delta x to the x variable in the given function. And recalling the formula for the sum and difference identities, this would be cosine of a plus b is equal to cosine of a times cosine of b minus sine a times sine b. So if we have, let's say a is x, and then b would be delta x, so we now have the limit of cosine x times cosine of delta x minus sine x times sine delta x minus the given function, which is cosine of x, over delta x. And notice that this part has a common factor with this part, and that would be cosine of x. So factoring that out, we have cosine x and then times cosine of delta x minus 1. And then just copy this middle term. So negative sine x times sine delta x over delta x. Applying addition theorem, we would be having this. And then since we're talking about the limit as delta x approaches 0, we can write this term as this one. So we can write cosine x in front of the limit here. And same with the sine x here. And then again, if we refer to this table of values for this function of cosine of delta x minus 1 over delta x, as we approach 0, f of x would be 0. So this is 0. And for this case, this would be the table of values. As we approach 0, f of x would be, or the limit would be 1. Therefore, we have cosine of x times 0 minus sine of x times 1. So this part is 0, and this part would be 1. So simplifying, this would be 0. So what's left would be negative sine x times 1, and that is negative sine x.